This is a key to test 2. In the first problem, it says divide, and I want you to write the answer in the form a plus bi. So you're dividing these two complex numbers. Now remember, when dividing complex numbers, you have to look at the denominator, and then to get rid of that I that's in the denominator, remember you're going to multiply both numerator and denominator by the conjugate of the denominator. So the conjugate of 2 plus 7i is 2 minus 7i. So you multiply both numerator and denominator by the conjugate. And now you're going to multiply numerators together, multiply the denominators together. And so if I FOIL the numerators, I get 3 times 2 is 6. And then the outer, 3 times a negative 7i is a negative 21i. The inner, I times a negative I times 2 is a negative 2i. And the last, a negative I times a negative 7i is a positive 7i squared. Doing the same thing in the denominator, I'm multiplying these two binomials. So I get 2 times 2 is 4. The outer, notice those are conjugates. So when you look at the outer and the inner, those are going to add up to be 0. So if you write it down, you'll end up being like this. 2 times a negative 7i is a negative 14i. 7i times 2 is a positive 14i. And then a positive 7i times a negative 7i is a negative 49i squared. And so combining like terms in the numerator, I have 6, a negative 21i and a negative 2i is a negative 23i. Now remember, I squared equals a negative 1. So this becomes 7 times a negative 1, so plus 7 times a negative 1, divided by, and then the denominator, combining the I terms, a negative 14i and a positive 14i, that's 0. Remember, when you're dealing with conjugates, the outer and the inner are going to be opposites. So when you add those up, you get 0. But you do have 4 minus 49, and again, I squared is equal to negative 1. So that becomes a negative 49 times a negative 1. Okay, now simplifying the parts here that you're multiplying by negative 1, we get this. 6 minus 23i, positive 7 times a negative 1 is a negative 7, divided by 4, a negative 49 times a negative 1 is a positive 49. And so this becomes 6 and a negative 7 is a negative 1. So negative 1 minus 23i divided by 53. And it does say right in the form a plus bi. So this becomes negative 1 divided by 53 minus 23i divided by 53. All right, so that's number 1. Now, number 2, that's an easy one in the fact that you're solving this quadratic equation. And so let's just go ahead and use the quadratic formula. So I'm going to put this in standard forms and bring all the terms to one side. So I get 4x squared minus 5x plus 2 equals 0. And so if you're using a quadratic formula, it's a good idea to denote what a, b, and c are. So a is a coefficient of x squared, so that's 4. B is a coefficient of the x term, so that's negative 5. And C is your constant, which is 2. And so using a quadratic formula, I get x equals the opposite of b. So the opposite of negative 5 is a positive 5, plus or minus the square root of b, which is negative 5 squared, minus 4 times a is 4, times c, which is 2. All of that is being divided by 2 times a, and a is 4. Simplifying the radicand, or the discriminant, I get 5 plus or minus the square root of 25. A negative 5 times itself is 25. A negative 4 times 2 is a negative 32 divided by 8. So it becomes 5 plus or minus the square root of a negative 7. 25 minus 32 is a negative 7 divided by 8. Now you have to remember that the square root of a negative 7 is, remember the square root of a negative 1 is defined to be I. So you're going to rewrite the square root of a negative 7 as I square root of 7. So this becomes 5 plus or minus I square root of 7 divided by 8. All right, so that's number 2. Number 3, You want to solve this quadratic equation by using the square root property. And so again, notice the part that's being squared, the term that's being squared is by itself. So at this point, and remember, using the square root property, don't use any other method but the square root property. So you're going to take the square root of both sides. Don't forget plus and minus. And so the square and the square root undo each other. So you get 4 minus 3x equals plus and minus. Now you have to remember that the square root of a negative 8, I can write this as the square root of a negative 1 times the square root of 8. All right, so that's going to be I right here. But 8, I can simplify 8 as 4 times 2. So this becomes the square root of a negative 1, square root of 4, square root of 2, and the square root of 4 is a perfect square. I'm sorry, 4 is a perfect square, so the square root of 4 is 2. So this right here becomes 2I square root of 2. So that is square root of negative 8. Square root of negative 8 is the same thing as saying 2I square root of 2. All right, so then we're going to subtract 4 from both sides. So I get negative 3x equals negative 4 plus or minus 2I square root of 2. And then dividing both sides by negative 3. I get negative 3 divided by negative 3 is 1. 1 times x is x. I get x to be negative 4 plus or minus 2I square root of 2 divided by negative 3. Or, now remember, let me go ahead and write this over right here. I'm going to go ahead and write this and put in, you could have also written it another way. But this is what you should remember is this. So negative 4 plus or minus 2I square root of 3 divided by negative 3. All right, so remember this right here, a negative divided by negative is a positive. So negative 4 divided by negative 3 means the same thing as 4 thirds. All right, so basically you're saying this. You're saying negative 4 divided by negative 3 plus or minus 2I square root of 3 divided by negative 3. So this is being divided by the denominator, and this is being divided by the denominator. But a negative divided by negative is a positive. So you see that 4 thirds here. A positive divided by negative, see this positive right here, divided by this negative, that's a negative. A negative divided by negative is a positive. So this right here means the same thing as plus or minus. And then 2I square root of 3 divided by 3. So you can write it like this, or you can write it as just one fraction so they have the same denominator, which would be 4 plus or minus 2I square root of 3. So this right here, a negative 4 plus or minus 2I square root of 2 divided by negative 3, that's supposed to be 2 right here, square root of 2, excuse me. Square root of 2. That's the same thing as saying 4 plus or minus 2I square root of 2 divided by 3. Okay? All right, so remember, I put square root of 3, but I meant square root of 2, each of those spots. Okay, so that's that one. Now, number 4, you have this square root equation, and so notice that the variables on both sides, and the variable x is also under the square root symbol. So you want to square both sides, but remember, you want to square both sides. First thing you want to do is get the square root symbol by itself, and it's already by itself. So I'm going to go ahead and rewrite this over. And so I'm going to square both sides. And so I get x squared equal, now the square and the square root undo each other, and so you're left with 4 minus 3x. So now notice I went from a square root equation to a quadratic, so let's go ahead and bring all these terms to one side. So I get x squared plus 3x minus 4 equals 0. And this is factorable, so I can go ahead and factor this quadratic equation. So I get x plus 4 times x minus 1 equals 0. And then using the zero factor property, I get x plus 4 equals 0, x minus 1 equals 0, and so my proposed solutions, my potential solutions are negative 4 and a positive 1. Now remember, those are solutions to this quadratic equation, but they may not be solutions to the original. So whenever you raise both sides to an even power, you may introduce extraneous roots. So you got to check for extraneous roots. And so it does say you must show that you checked for extraneous roots. So let's go ahead and check. So let's check x equal negative 4 first. So always go back to the original equation, which is this. So you have x equal the square root of 4 minus 3x. That's the original equation. So wherever I see the variable x, I'm going to substitute negative 4. So I get negative 4. I want to see if that's going to equal this side, which is the square root of 4 minus 3 times x, and x is negative 4. And so negative 4 is on the left side. On the right side, again, you're checking to see if those are equal. On the right side, this becomes 4 plus 12, 4 plus 12, which is 16. And the square root of 16 is 4, and those are not equal. Okay, negative 4 does not equal 4. So that means that this right here is extraneous. So that's an extraneous root, so that's a false root. It's a solution to this quadratic, but it's not a solution to the square root equation. So now let's check x equal 1. So we're going to check x equal 1. So again, go back to the original, which is x equals the square root of 4 minus 3x. And where we see the variable x, you're going to substitute 1. So you want to see if 1 equals the square root of 4 minus 3 times 1. Well, 3 times 1 is 3. 4 minus 3 is 1. So this right here becomes the square root of 1. And the square root of 1 is 1. And notice those are equal. 1 equals 1. So x equal 1 is our solution. That's the only proposed solution. That's a solution to the original equation. All right, so that's number 4. All right, number 5, we have this for number 5. So in number 5, you're given 2 points, negative 22 and negative 13.5, and you would find the distance of the midpoint of the segment joining, of the segment that has those endpoints. Okay, so it's a good idea to label these. So let's call this our first point and this our second point. So this is going to be x1, y1, x2, y2. And so part A says find the distance. So this will be part A. So the distance formula is the square root of x2 minus x1 squared. So you subtract your x coordinates from each other and you square that difference, plus and then y2 minus y1 squared. All right, so we're just going to substitute. So this becomes the square root of x2 is a negative 13. So I get a negative 13 subtract a negative 20 squared plus y2, which is 5, subtract y1, which is 2, and I square that as well. So this becomes the square root of, now negative 13 subtract a negative 20 is a negative 13 plus 20, and don't forget to square that. And then I'm going to go ahead and rewrite this over. 5 minus 2 squared equal the square root of. Now negative 13 plus 20 is 7. So I got 7 squared plus, and then 5 minus 2 is 3. So I got 3 squared. So as the square root of 7 times 7 is 49. 3 times 3 is 9. So you get the square root of 58. And then the only perfect square that goes into 58 is 1, so that cannot be simplified. So there's the answer for the distance between those 2 points. Part B, it just says find the midpoint. So the midpoint formula is this. That's where you add your x coordinates together and divide by 2. Don't forget it's a point, so you need parentheses. And then you add your y coordinates together and divide by 2. So it's just the average of the x coordinates and the average of the y coordinates. And so you just substitute. So your x1 is negative 20, x2 is negative 13, y1 is 2, y2 is 5. All right, so this becomes negative 20 plus the negative 13 divided by 2, comma, and then 2 plus 5 divided by 2. And then which equals negative 20 plus the negative 13 is a negative 33 divided by 2. And just leave it as this fraction. It's already in reduced form. And then 2 plus 5 is 7 halves. So just go ahead and leave it as a fraction, and because if you write a decimal, that's fine because it terminates, but sometimes when the decimals don't terminate and you round off, you're going to lose points. So just leave it as a fraction in reduced form, and negative 33 halves and 7 halves are reduced. So that's your midpoint. So that's number 5. Okay, number 6 says you have a circle with diameter with the following endpoints. So the endpoints of the diameter are negative 3, 4, and 5, 8. And you want to find the center of the circle. Well, remember the center of the circle is the midpoint of the diameter. So that's the midpoint of the diameter. And so in the previous problem, you already know how to find the midpoint. So let's go ahead and label these. This is x1, y1, and this will be x2, y2. And so in part A, remember the center is the midpoint. So you're going to find the midpoint of this segment, this diameter. So don't forget it's a point, so you need parentheses. So you're going to say negative 3 plus 5 divided by 2, comma, and then 4 plus 8 divided by 2. Negative 3 plus 5 is 2, so you get 2 divided by 2. 4 plus 8 is 12, so you get 12 divided by 2. And so reducing this, 2 divided by 2 is 1, 12 divided by 2 is 6. So you had to say 1 6, not this, because you got to reduce. You know how to reduce. Okay, part B, this time you want to find the length of the radius. Now remember, that's the diameter. Well, we know that the length of the radius is half the length of the diameter, right? So let's just go ahead and find the length of the diameter. So using the distance formula. So remember the distance formula, x2 minus x1 squared plus y2 minus y1 squared. And so just substituting this information into here, we get the square root of x2 is 5, subtract a negative 3. So 5 subtract a negative 3 squared, plus, and then subtract the y coordinates, 8 subtract 4 squared. So that becomes the square root of 5 subtract the negative 3 means 5 plus 3 squared, plus, and then 8 subtract 4 is 4, so you get 4 squared there. 5 plus 3 is 8, so this becomes 8 squared plus 4 squared, which is the square root of 8 squared 64. 4 squared is 16. All right, so 60, adding those two terms together that's in the radicand, we get 64 plus 16 is 80, so that's the square root of 80. Now, you can simplify this if you want to, so you can say, well, the square root of 80 will be, remember the square root of 80, let me go ahead and put that one here. So the square root of 80, if you recall, if you want to simplify it, I would leave it like this for right now, because remember, that's the diameter, so be careful. That's the length of the diameter. So the perfect square that goes into 18 is 16. So it'll be the square root of 16 times the square root of 5, and the square root of 16 is 4. So you get 4 square root of 5. So that's the length of the diameter. Okay, but remember, you're trying to find the length of the radius. So you're going to say the length of the radius. You can do one of two things. You can use the square root of 80, so it'll be the square root of 80 divided by 2. Now don't say 80 divided by 2 is 40, because that's not 80 here, that's the square root of 80. 80 and the square root of 80 are not the same thing. Or you could have said 4 square root of 5 divided by 2. So it'll be 2 square root of 5. Alright, so either one of those is fine. So remember, we got that by saying 4 square root of 5 divided by 2. Okay? Alright, so that's the length of the radius. Alright, now part C, you want to find the standard form of the equation of the circle. So remember, the standard form of the equation of the circle has this form. X minus h squared plus y minus k squared equals r squared. And so we already found the center. So there's your h, there's your k. So h is 1. So that's your h. There's your k. So h is 1, k is 6. So that becomes x minus 1 squared plus y minus 6 squared equals, now the radius, I'm going to go ahead and use this one. It doesn't matter, you can use this one as well, but I'm going to use this one. So don't forget though, I'm squaring the radius. So the radius is the square root of 80 divided by 2 squared. Now don't leave your answer like this. You from experience, you know that you need to simplify this. So on the side, remember the square root of 80 divided by 2 times itself, right? Square root of 80 times square root of 80 is 80. 2 times 2 is 4. And 80 divided by 4 is 20. So your answer that you're going to give for the equation of the circle is going to be x minus 1 squared plus y minus 6 squared equals 20. All right, so that is number 6. Okay, number 7. So number 7 is where you want to solve this system of equations, but using substitution. So remember, when using substitution, you got to pick one of these equations, and usually the easiest one to pick is the one that has a coefficient of 1. And this one does. So the second equation has a coefficient of 1, and you want to solve for that variable. So it's easier to pick that second equation and solve for x. All right, so if you picked any other equation or any other variable, like even this right here, you'd have to divide by 6 here, and that would introduce some fractions. So it's easiest to solve for x. So step 1, you would say, well, you're going to pick the second equation, and you're going to solve for x. So x equal 33 minus 6y. All right, that was step 1. So you just solve for x in this case. Step 2 is where you're going to take what you just solved for x, so this expression here, you're going to substitute that into the other equation, or into the other equation. So I get 5 times 33 minus 6y plus 3y, so 5 times, and then remember this becomes 33 minus 6y plus 3y equals 3. Plus 3y equals 3. All right, now solving, now notice all you have now is an equation with one variable, so let's go ahead and solve for this y. So we're going to distribute. So 5 times 33 is 165. 5 times a negative 6y is a negative 30y plus 3y equal 3. Combine like terms. A negative 30y and a positive 3y is a negative 27y. So negative 27y plus 165 equals 3. Subtracting 165 from both sides, I get negative 27y equal a negative 3, and a negative 165 is a negative 162. Divide both sides by negative 27. Negative 27 divided by negative 27 is positive 1. 1 times y is y. So I get my y coordinate of my solution to be 6. To find the x coordinate, you go back to either one of those equations, but I'm going to go back to step 1 since x is already by itself. So step 3 is to solve for x now. So let's go back to this one. So we have x equal 33 minus 6 times y. I just found y to be 6. So that's 33 minus 36. And so x coordinate is going to be 33 minus 36 is a negative 3. So your solution as an ordered pair, x and y, so x is first, is negative 3, 6. All right, so that's number 7. Number 8, again, you want to solve a system, but this time you want to use addition elimination method. And so when using addition elimination, it does not matter which you eliminate first, either the x's or the y's, does not matter. I'm going to do both just to show you what you would do. So if you want to eliminate the x first, so let's say some of you want to do that. So you want to eliminate the x. So remember, you got to eliminate the x's, you want the coefficient of x to be opposites. So you got to find the least common multiple of 2 and 3. So the least common multiple of 2 and 3 is 6. So you need this to be a 6x and this to be a 6x as well, but opposite. So you need one of them to be negative though. All right, so let's go ahead and look at what we're going to do. So I'm going to write the first equation over. All right, and remember I want this to be a 6 right here, so I have to multiply this by 3, but you're going to multiply both sides of that equation by 3. And let's make this one negative. So this is 3x plus 2y equal 8. So this time I multiply by negative 2. So times negative 2, both sides. Okay, now that's going to guarantee that when I add these two equations, the x's will be eliminated. So now if I distribute, I get 3 times 2x is 6x, 3 times a negative 5 is a negative 15y equal, and then 37 times 3 is 111. The second equation, negative 2 times 3x is a negative 6x, negative 2 times 2y is a negative 4y equal, and then 8 times 2 is a negative 16. Now I can add these, because when I add these now, the x's will be eliminated. Now negative 15y and a negative 4y is a negative 19y. 111 subtract 16 is 95. All right, so getting y by itself, divide both sides by negative 19. I get my y coordinate of the solution to be negative 5. 95 divided by negative 19 is negative 5. Now to solve for, remember the next step is to solve for x. It does not matter which equation you go back into. You can use the first one or the second one. Let's go ahead and use the second one. The numbers are somewhat smaller and they're all positive coefficients. So this is going to solve for x. So 3x plus 2 times y. I just found y to be negative 5. So 2 times negative 5 equal 8. And so solving for x, I get 3x minus 10. 2 times negative 5 is negative 10 equal 8. Add 10 to both sides. I get 3x equal 18. Divide both sides by 3. And I get x to be 6. So there's my x coordinate. There's my y coordinate. So my solution is going to be, remember, x as an ordered pair, it's xy. So 6 comma negative 5. All right. Now, if you wanted to eliminate, so someone else could have eliminated the y's instead. So let me just show you what you would have done if that would have been the case. So let's go ahead and eliminate y. So to eliminate the y, again, the coefficient here is negative 5. The coefficient here is 2. The least common multiple of negative 5 and 2, the smallest number that negative 5 and 2 go into evenly, is 10. Now, this is already negative. This is already positive. So that's going to help us somewhat. All right, so I have 2x minus 5y equal 37. And then 3x plus 2y equal 8. All right, so I want this to be a negative 10, which means I have to multiply both sides by 2. Negative 5 times 2 is negative 10. So times 2 times 2. This is 2y. I want 10, so I have to multiply that by 5. So I'm going to say times 5 times 5. All right, now distributing, I get 2 times 2x is 4x. 2 times negative 5y is a negative 10y equal, and then 37 times 2 is 74. Over here, 5 times 3x is 15x. 5 times 2y is 10y equal 40. Now I can add these because now when I add these are opposites, so they will become 0, the y's. So 4x and 15x is 19x equal, and then 74 plus 40 is 114. Divide both sides by 19. I get x to be 14 divided by 19 is 6. And those are the same as we got here. Okay. Now to find the y coordinate, you're going to solve for y now. And again, go back to either one of those. It does not matter. You can go back to the second one again if you want to. Let's just go back to the second one. Actually, let's go to the first one just because I just want to remind you what to do with that negative coefficient. So I'm going to do it to the, it's easier to use the second, but I want to do the first one. So we're going to solve for y. So we're going to say 2 times x is 6, minus 5 times y equal 37. 2 times 6 is 12, so you get 12 minus 5y equal 37. Subtract 12 from both sides. I get negative 5y equal 37. Subtract 12 is going to be 25. Divide both sides by negative 5. I get y to be negative 5. And so the solution, remember x, y, ordered pair, so solution will be the same as the other one, 6, negative 5. All right, so that's what you would do if you eliminate the x's first, and that's what you would do if you eliminate the y's. All right, so that's number 8. Okay, number 9, you want to find the difference quotient for this function. Well, remember the difference quotient, the formula for the difference quotient is f of x plus h minus f of x divided by h. All right, so step 1, remember, let's do this by steps. So step 1 is to find this part first. Let's go ahead and find f of x plus h. So wherever we see the variable x, I'm going to substitute x plus h. So I get negative 2 times x plus h squared plus 3 times x plus h plus 4. All right, now I've got to square this x plus h. So you've had enough experience squaring x plus h. So you know that x plus h squared means x plus h times itself. And so if I FOIL this, x times x is x squared. The outer is xh, also is the inner, xh. So I get 2xh, and then h times h is h squared. So that is just this part here, but that's being multiplied by negative 2. So this becomes negative 2 times x squared plus 2xh plus h squared. And then let's go ahead and distribute the 3 now. So that'll be plus 3x plus 3h plus 4. distribute the negative 2 through here, I get negative 2x squared. A negative 2 times 2xh is a negative 4xh. A negative 2 times h squared is a negative 2h squared. And then plus 3x plus 3h plus 4. Now there are no like terms, so that's all I can do here. So that was step 1. Step 2 is where you take what you did in step 1, you subtract your function from it. And remember, your function is this. So step 2 is to find f of x plus h minus f of x. So we just found f of x plus h, that's all of this. Let me rewrite all of this. That's negative 2x squared minus 4xh minus 2h squared plus 3x plus 3h plus 4 minus, in parentheses, f of x. But be careful, make sure you put in parentheses because you're subtracting all these terms. And this is f of x right here. So minus 2x squared plus 3x plus 4. Now getting rid of the parentheses, distributing the negative, this becomes negative 2x squared minus 4xh minus 2h squared plus 3x plus 3h plus 4. The opposite of a negative 2x squared is a positive 2x squared. The opposite of a positive 3x is a negative 3x. And the opposite of a positive 4 is a negative 4. If you're doing this correctly, remember all the terms that does not have a factor of h, its opposite better be there, and when you add them up, you get 0. So notice negative 2x squared, positive 2x squared, its opposite. Those are opposites. When you add them up, you get 0. This doesn't have an h, so 3x, negative 3x, that's 0. 4, negative 4, that's 0. What's left, notice what's left have a factor of h. So let's go ahead and factor out that h. So that becomes h times, remember you factor out an h, so that's negative 4x. That's all you better put there. Don't put an h. Some of you put an h for some reason, but h times h is h squared, and that's not what that is. That's an h. Minus 2h. H times negative 2h is a negative 2h squared. And then h times 3 is 3h. All right, so that's your step 2. Step 3 is now where you take step 2, take all of this and divide by h. So that's this. So step 3 is f of x plus h minus f of x divided by h. So the numerator is what we just found, so that's h times negative 4x minus 2h plus 3 divided by h. The h's divide out, and you're left with what's in parentheses. So you get negative 4x minus 2h plus 3. So that's the difference quotient. That's the difference quotient for this function. All right. Now, in number 10, you want to determine whether each of the following relations is a function. So notice that what you may want to do for part A and B is to use the idea of a mapping. And so basically this will be part A. So in part A, if you think of this as a mapping, so there's your domain, there's your range. And so when x is 3, your y value is negative 1. So remember, the definition of a function is that for each x coordinate, there's got to be just one y coordinate. And so far we do. When x is 3, there's only one y coordinate attached to it. When x is 4, same thing. There's only, and remember, only write it once. Only write it once. So when x is 4, there's only one y coordinate. It doesn't matter. Remember, it does not matter that different x coordinates have the same y coordinates. It does not matter. Still the idea of a function. When x is 5, the y coordinate is 3. And when x is 6, the y coordinate is 1. So that's a function because for each x coordinate, there's only one y coordinate. So that is a function. In part B, so this is part B, using the same idea, domain, range. So when x is negative 2, my y coordinate is 3. When x is 4, my y coordinate is negative 4, so far we're okay. That's a function. When x is 5, my y value is 7. But here's a problem. Again, only write it once. When x is negative 2, I have another y coordinate, which is 8. So when x is negative 2, there are two different y coordinates. So that's not a function anymore. So that's not a function. Now notice in part C, you had to recognize that y plus x is equals 7 is a line. That's a line. And if you were to get y by itself, if you get y by itself in part C, you get y equals 7 minus x. So the slope here is -1. So basically you get a line that looks something like this. So that's a function. It passes a vertical line test. So that's a function. All right. Now for part D, you had to know that that's a quadratic function, and you dealt with quadratic functions in one of the My Math Lab sessions. And so that's a quadratic function. The graph is a parabola. In fact, it looks something like this. So you know what x squared looks like. It's moved up 1. So that's this right here. So that passes the vertical line test. So that's a function as well. And even if you didn't know what the graph looked like, what you should have done was do a t-table. So remember, for each definition of function, for each x coordinate, there's only one y coordinate. So when x is 0, this becomes 0 squared plus 1, right? Which is 1. So for this x coordinate, there's only one y coordinate. When x is 1, this becomes y equal 1 squared plus 1. 1 squared is 1. 1 plus 1 is 2. All right, so for this x coordinate, there's only one y coordinate. When x is -1, I got -1 squared plus 1, right? So -1 squared is 1. 1 plus 1 is 2. So again, it doesn't matter that two different x coordinates have the same y coordinate. That goes back to this one here. It's still a function. And regardless of how many times you do this, for each of these x coordinates, there's going to be one y coordinate. So that's a function. All right, so that's number 10. Number 11, all right, so this is where you're given two different functions and you want to find these function values. So the first, now notice that this right here is function f and this right here is function g, so make sure you're using the right one. So this says you want to find g of -2, so I got to go to my function g, and in place of x, I'm going to substitute -2. So g of -2, so wherever you see the variable x, you can substitute -2. So this becomes 3 times -2 squared minus 4 times -2 plus 1. Order of operations, -2 times itself. Remember, you do the exponent first. You don't multiply and then square. You gotta square first and then multiply. So -2 times 2 is, -2 times -2 is a positive 4. 4 times 3 is 12. So that's 12. -4 times -2 is a positive 8, and then plus 1. 12 plus 8 is 20. 20 plus 1 is 21. So the answer for that one is 21. For this one, so this you go to function f this time, and now where we see the variable x, you're going to substitute 2x plus 1. So this becomes 3 times 2x plus 1 minus 2. And then let's go ahead and get rid of the parentheses. So you got to go further with this. So 3 times 2x is 6x. 3 times 1 is 3 minus 2. And so now you get simplified form of 6x, and then 3 subtract 2 is 1. So that's 6x plus 1. All right, so that's number 11. All right, number 12. So in number 12, you're given this function, which is just a finite set of ordered pairs. 1, 2, 3, 4, 5. Now remember what f of -1 means. So f of -1 means what is y when x is -1. That's your x value here. So when x is -1, your y value is 2. So that's x equal -1, y value 2. So the answer there is 2. This says, well, first of all, find f of 6. So again, f of 6 is what's the y value when x is 6? Well, when x is 6, your y value is 9. So there's x, there's y. So this becomes 2 times 9, which is 18. All right, so that's letter B. And then you continue on. So in part C, you have f of 0 plus f of 2. Well, f of 0, remember, f of 0 means what's the y value when x is 0? Well, when x is 0, my y value is -7. So this becomes -7 plus, and then f of 2. Well, f of 2, what's the y value when x is 2? Well, my y value is -5. So 7 plus a -5 is a -12. And then part D, f of 6, same thing. So f of 6 is 9. So that's 9 minus 2 times f of negative 3. So when x is negative 3, your y value is 4. So that's 2 times 4. So it becomes 9 minus 8, which is 1. So the answer is 1 there. All right, so that's number 12. Okay, 13, so you're given the graph of a function and you want to find the domain and range. So remember, the domain is a set of x coordinates. Now, if you need to, you may want to kind of use a straight edge and to help you with this. So remember, the domain is a set of x coordinates. So you're going to go along the x-axis and you're going to see where your x values start. Notice this is an open circle, that's a closed circle, so remember what that means. One's going to be open circles, parentheses, closed circles, brackets. So that point right here where the graph starts at that open circle, which is negative 8, so that point's not on the graph, but I still have to use that number in the graph. I just have to use parentheses. So my domain's going from negative 8, parentheses, negative 8, comma, all the way to, and then it stops here at positive 6. And notice that point is on the graph here, which has x coordinates 6. So I gotta use a bracket. The range this time, you go from bottom up along the y-axis. So again, notice that when I go along the y-axis, my y values start here, this open circle. So that's parentheses negative 4, comma, all the way to this y value, which is a positive 4, but that's a closed circle, so it'll be a bracket. All right, so that is number 13. 14, same thing, domain and range. Notice though these have arrows that are both pointing up. So notice though that this arrow indicates that it just keeps going up this way. So just think of this arrow is pushing the ruler towards the left. So you're going from negative infinity, because there's no starting point along the x-axis. You go from negative infinity, same thing here. It never stops because of the arrow. All right, so you go from negative infinity to positive infinity. And remember, whenever you're dealing with negative infinity and positive infinity, you use parentheses. Don't ever use brackets. And then for the range, notice that your starting point is here on the range. That's a closed circle, and that's negative 6. So you're going from negative 6 all the way to infinity. Bracket, negative 6 to infinity. All right, so that's 14. And in 15, you want to determine which graph best represents this equation. And it's the same thing just like you had a while ago. We talked about a while ago. See, this is y equal x squared plus 1. This is y equal x minus 2 in parentheses squared. So they're both quadratic. So you'll have a parabola as the shape of the graph. But if you're not sure which one of these to use, just use a t-table to help you. But hopefully through the lessons, when you did these lessons a while back, you use the idea of translations. So remember, when y equal x squared is your parent function, which looks like this. So that's y equal x squared, where the vertex is at the origin. Now, if the number's on the inside of the parentheses, that's a horizontal translation. Many students, though, get that negative 2 confused, so they think it's actually being translated to the left, but it's not. The inside, if the number's on the inside, it's kind of counterintuitive. You're actually translating it to the right. So just because you see that negative 2, don't think you go to the left 2s. You actually do the opposite. You go to the right 2. So part B would be the answer for that one. But if you did not know that, use a t-table. That's all you had to do. If x is 0, watch how easy this is. You had to use a t-table. If x is 0, you get 0 minus 2 squared. So that's the negative 2, right? So the negative 2 times itself is 4. So you get 0, 4. All right. So now notice, you want to find a graph that has 0, 4 on it. Well, this one does not, so that you kind of delete that part out. Here 0, 4, the graph does not go through it, so that's out. But these two have 0, 4 on the graph. So let's continue on. If x is, let's say, 2, if x is 2, I get 2 minus 2 squared, 2 minus 2 is 0. 0 squared, 0. So I got to look for a graph that has the point 2, 0 on it. Well, this is the only one that does. This is not. That's negative 2, 0. So that's the 1. All right. So that's a graph. But the idea was to have used the idea of translations. So when it's on the inside, that's a horizontal translation. But don't let that part confuse you. Don't think negative 2 means you go to the left 2. You've got to think of the opposite. That horizontal translation throws students off. So you got to go to the right 2. So it's actually this one. So you take the parent function and you go to the right 2. All right, so that's the answer for 15. So that was test number 2. So let me go back to that first page. So test 2, so that was the key to test 2.